something very important before we start. Calculation questions, you need to understand the questions. Okay, sometimes the question is very simple. A very simple calculation is involved, but the way the question wording is written is not very clear. So you need to make sure that you understand the question first. Also, one thing that you need to highlight what the question is asking. So in this question, you are asked to calculate the initial dose of aminophylline injection, 25 milligrams per ml. Now, this is the strength of the injection or the concentration of the injection given for a 5-year-old child who has breathing difficulty. So the child weighs 26.5, is it 26? 26.5 pounds. So the child weight is 26.5 pounds, and the recommended dose given is 5 milligram per kg. Okay, another thing just came to my mind. In university, you might have some questions. For example, in therapeutics exams, I used to give the questions where, especially in OSCE also, where the question is given but some information is missing. And you are expected to look for that information from the monograph. Okay? In SPLE, it's not like that. In SPLE, everything you need for the question is given in the question. Okay? If it's not given in the question, then that means you are supposed to remember that. Okay? So coming back to this, so the recommended dose is 5 milligram per kg, but you can see the weight given is in 26.5 pounds. And what we are asked is what is the volume of aminophylline injection? Okay, so the first thing we'll do what? Convert weight pound from to kg. So we know that 1 pound is equal to 0.45 kg. So 26.5 pounds will be how much? Yes, something 11.9, approximately 12 kg. So just round it up. So the weight of the patient here is 12 kg. That's what we work with. The next thing we're given here is the dose, which is 5 milligram per kg. So the dose given here is 5 milligram per kg. So that's 5 times 12. So that's 60 milligram. So we have got the dose now. Okay. The dose is being given. So the dose for that patient is 60 milligram, but the question is asking what volume. Okay, that is most likely to be in milliliters. So we know the dose the patient needs is 60 milligram, and so we need to find out how many milliliters of aminophylline we will give that will provide the patient 60 milligram of the dose. Okay, so for that we need this information, the strength of the injection. Okay, so if strength of the injection is given as 25 milligrams per mil. So that's the strength of the injection. Now that means if 25 milligrams is present in 1 milliliter, according to the strength of the injection, 60 milligrams will be in. The way I do this calculation is this. I'll show you the way I do it, but if you have your own method of calculating this type of calculation, then stick to that, because I don't want you to learn something new at this point. So if 25 milligram is present in 1 milliliter, 60 milligram will be in, so that's how I do it. So this divided by this, multiplied by this. So that will be 2.4 milliliters. So the answer here is 2.4 milliliters. So we need to give 2.4 milliliters of aminophylline that will provide 60 milligram of the dose. You're asked to advise on what volume of amiodarone sterile concentrate should be added to 500 milligram dextrose 5% to provide amiodarone dose of 600 milligrams. So the dose here is 600 milligram. The amiodarone is to be administered by IV infusion, and this is the infusion solution. Express your answer in milliliters, and the strength of the injection here is 50 milligram per ml. So it's pretty much the same as the first one question, but here you have something else here, which is this. Okay. Now, sometimes in questions like this, you are given this information just to confuse you, okay? This information, 500 milliliters of dextrose, 5%, is just given to confuse you. Do not try to use that in the calculation, okay? Just imagine that this is the solution, that's it. Just ignore that. If you ignore that, the rest of the calculation is the same. So we have to give 600 milligram of the dose, and the strength of the solution given is, injection is 50 milligram per milliliter. So how many milliliters I will take from this that will provide 600 milligram dose? Okay, so it's 50 milligram is present in 1 milliliter. 600 milliliters will be in, okay, so 1 divided by 50 times 600. So it's this divided by this times this, and the answer is 12 milliliters. Here, a 35-year-old patient has been prescribed sodium bicarbonate capsules. Okay, by the way, there's something I forgot to tell you, that after every type of calculation, we will have a little quiz competition. So today, after dose calculation, we'll have a little quiz competition, and then we'll have some other type of calculation and some little competition, and then we will see who wins at the end of the day. Okay, so I have 8 questions for dose calculation. After this, I think we'll have a break for prayer in between, and then when we come back after the break, we'll have the quiz competition, which will have questions related to the dose calculation. Okay, so pay attention. A 35-year-old patient has been prescribed sodium bicarbonate capsules for the correction of metabolic acidosis. She is to take 1 capsule a day. Each capsule contains 500 milligrams of sodium bicarbonate. The molecular mass of sodium bicarbonate is 84. How many millimoles of sodium and bicarbonate would this patient take in 1 day? So now here you are supposed to know the formula for millimoles. Okay, so everybody remembers from chemistry? They remember how to calculate millimoles. Okay, the formula for millimoles is equal to weight in milligrams, because it's millimoles, divided by molecular weight. Now this is the equation you need to remember. In SPL, if you get a question like this equation will not be given. Okay. So millimoles, weight in grams is given to us, that's here. It's 500 milligrams, so we need to find out how many millimoles are present in 500 milligrams of sodium bicarbonate. So 500 milligrams divided by molecular weight is given here as well, which is 84. So the number of millimoles is, yes, it's round about 5.95 and round it up to 6 millimoles. There is one thing you need to note here, is that the question is asking about how many millimoles of sodium, but we have worked out for sodium bicarbonate, right? Because this 500 milligrams is of sodium bicarbonate, molecular weight of sodium bicarbonate, but the question is asking about sodium. Now, in a question like this, you need to see that sodium bicarbonate formula has a valency of sodium. It's 1 sodium and 1 bicarbonate. So if you remember from your chemistry, it will produce in a solution 1 millimole of sodium and 1 millimole of HCO3. So it's the same actually, because it's producing 1 and 1. Okay, so for these type of calculations, just remember the number of mole, this equation. This is important to remember. If you are asked a question where it's asking about moles, so the equation for moles is what? The same equation, but the weight should be in weight in grams and molecular weight. So this was an equation for millimoles. Millimoles is equal to weight in milligrams divided by molecular weight, and if you're asked to calculate the moles, it's moles divided by, so moles is equal to weight in grams divided by molecular weight. Because it has one valency. In sodium bicarbonate, one molecule, you have one sodium and one bicarbonate. Okay, that's why it remains the same. If you had something like different, for example, calcium chloride, where in the formula you have 2 chlorines, there would be a different thing. That would be a different thing, because in calcium chloride, you have 2 chlorines in one molecule. Here, sodium bicarbonate, in one molecule, you have 1 sodium and 1 bicarbonate. Okay, in this question, we calculated taking 10 capsules in one day. Each capsule has 500 milligrams. And we are asked to find out how many millimoles the patient will receive in one day. So remember here, in one day, the patient is receiving 10 capsules, and each capsule has 500 milligrams. And we calculated that each capsule, which is 500 milligram, has 6 millimoles. But the patient is receiving 10 capsules, right? And we need to find out what's in a day. So basically, we just need to multiply this by 10. So the answer here would be 60 millimoles. So again, importance of reading the question carefully. Okay. I just missed that. Thank you, Abdulaziz, for spotting that out. Very important question. Patient is on remission from leukemia and has prescribed oral methotrexate 25 milligrams per meter square. Now, if you haven't come across on anti-cancer drugs, you would not know that the doses of anti-cancer drugs are based on body surface area. And if the dose is based on body surface area, it's written like this: 25 milligram per meter square. You remember that in the previous questions we have seen the doses based on weight. So that was something like 25 milligrams per kg. The dose, that means this dose is based on a weight. If the dose is given as 25 milligrams per meter square, this dose is based on body surface area. Okay? So if the dose is given like this, you need to work out first of all the body surface area. Okay? Now, upon checking the medical notes, you find that the patient is 0.9 meter tall, that's the height of the patient, and 12 kg weight. What is the weekly dose of methotrexate? Now, as I said before, for the dose is based on body surface area here. So we need to work out first the body surface area. And the equation for body surface area is this. It's height in centimeter multiplied by weight in kg divided by 3600, and you take the square root of that. So you've got all the values, just plug it in the equation. Height is given as 0.9 meter. 0.9 meter, but I want that in centimeter. Okay? Meter is a bigger unit, centimeter is a smaller unit. I'm moving from a bigger to smaller unit. The decimal should move towards the right. And how many places here? Here 2 places. Okay? Here the decimal will move 2 places because there is 1 meter has 100 centimeter. 1 meter has 100 centimeter. 1 meter has 100 centimeter. So the 100 has 2 zeros. So the decimal will move towards right by 2 places. So 1, 2, and this will be 90 centimeter. So you've got all the values now. So what's the body surface area? 0.54 or 55? 55. So if you round it up, it's 0.55, and let's round it up to 0.6. So the body surface area of this patient is 0.6 meter square. How do we calculate the dose now? So it's 25. This is the dose present here. So it's simply 25 times 0.6. The dose is, okay, is everybody clear?